This outlet for the neutral side has the silver screws, which is the neutral or the grounded conductor. It's not technically a neutral, it's called a grounded conductor. You have the ground, okay? So the ground, and then the grounded conductor right above it, which is the neutral. Then you have the brass screws, which is the hot side, okay? Which, that would be the black. The silver is the white, and the green is the bare. Now, with this outlet, we have to cut the power off. Some electricians don't cut the power off, but I'm going to show you about the power. Now, if you look real close at ground, something's inside this bottom ground. Okay, that's one of the reasons why we're changing it. So we're going to stick a little tester, which our little tester here, pretty cheap. You can buy them at Lowe's. You have 2 green lights, which indicate correct, and then it'll show you different lights, which is what that would be. Something's wrong. Okay, so we have this tester. We also have a tester, a meter, okay, which we will be doing a video, on how to use a meter. But for this video, we're going to go to voltage. Okay, this is AC and DC current. Okay, all right, this is an amp so that we can tell how much power is being used through, but that is voltage. Okay, so right now we're going to be shoving these metal prongs right inside of the outlet, which gives us 122.3. Okay, we can check. So that was the hot side, and then we can stick into the ground. Here, my meter, ground, 122.6. So we know that the ground is on the right side, because if I touch the neutral and the ground at the same time, we don't get anything, which that says 0.06, which is pretty much, there's no voltage. Okay, all right, so now that we know there's voltage on the outlet, we're going to open up our panel. We're going to go, this should be an electrician's in their thing, it should be labeled correctly, but it's not. But I know which one it is. We're going to cut the outlet off, the circuit off going to that outlet. So put this back in. There's no lights. I don't like the little beepers that people use to check to see if they're hot, because they can always show 12 volts and you could say, hey, something's not right on that. So now that we can actually see there is no voltage. That's 0.4. So there is no voltage. We'll just check that again. Nothing on there. All right, so now it is good to start removing. Start taking this outlet out. So on this outlet, there is pretty short wires on this outlet, which I do not agree with. We should have some extra wire, but it's not going to hurt anything. I'm just going to start disassembling this outlet. All right, now for our new installation, we want to make sure that these things are stripped long enough. Okay, some of these short wires here, so I'll show you compared to what I stripped it. We stripped it just a little bit longer. Also on the back of this, you can physically see there's a gauge right here. And look at that. I stripped that thing dead on. So on this one, there's just not enough. You can see we need a little bit more. So I'm gonna make sure that all of these are stripped appropriately. And now with these, I am using a pair of side cutters, so I am a professional. At least that's what they say that I am. But normally you would have a pair of strippers, but I can use the side cutters and know that I'm not damaging the copper here. You start damaging the copper, then you get yourself in trouble. Also, there is a ground clamp there, which is called a crimp sleeve. I'm gonna make sure that those grounds are together. Move it around, make sure it's not loose. Everything's together. And we can give a little bit of fish hook here so that I can reattach to the outlet. So your ground wire here goes around your screw. So where you're turning your screw, make sure that we're here, where you're turning your screw clockwise, making sure that your fish hook is the same way. All right. All right. Okay. I'm gonna take a Phillips. What I like to do is just give that thing a little crimp. Get that thing around. And now for the controversial part. Okay. Many electricians say, oh, you got to wrap these things around the screws, which is just fine and dandy, but when you're wrapping them around the screw, you can't forget to tighten the screw, because I've changed more outlets that were burnt up because they were not screwed in properly. So for me as an electrician, I like to see just enough copper to make sure that that thing is all the way in. Okay, that tells me that it's all the way in. I strip them just a little bit longer so that I know that I bottomed that thing out. And when it's bottomed out on the outlet, we know that it's in there securely. It's manufactured that way. I'm going to use it that way. Now this is 14 gauge wire. This is not a kitchen outlet, okay? All right. All right. So any 12 gauge wire, you will not be able to punch it through the rear, okay, or stab in the back, whatever you want to call it. And then make sure that you get at least a good 4 or 5 spins out of that screw going into that box. Okay, nice and tight. Where it just bends just a little bit. That's how I know it's just barely clamped on. Then I can take my cover, put this on. I don't like these little hard covers, but that's what we got. Down. Okay, nice and tight. Nice clean outlet. Now we're going to go back to our panel. Breaker's off. Back on. Now, nothing popped. The breaker didn't kick back. I don't see any smoke. So I think maybe we've done this correctly. All right. I know we did. I'm joking. All right. I'm gonna put this back in. We'll see that everything's correct. Okay. Now, for our meter test, Okay. Now you can see I can't just punch a wire, punch something in there. Okay. Alright, I have to have two. What I'll do, slides right in there. And you hear that little beep. My meter, 123, which is more than acceptable. I'm gonna pull that one out for the ground and see when both of them are to press in, I can go in and out on the other one. But I'm gonna touch the ground. 123 ground. I know it's wired correctly.